Did I give you the numbers for the second one?
All right, guys. Try to make sure you get at least one interval created if you're kind of working by yourself. If you're working amongst other people, then get your one done, and then kind of come together. Help me out here. Who's got? So I've numbered them 1, 2, 3, 4. So this is from basically last semester. This is now. You guys are actually kicking these guys' ass. Yeah. I feel so bad. But on the first one, who's got the mean for the females from last semester?
74.63.
74.63. And what's the standard deviation for those guys?
10.58.
10.578?
Yeah.
Okay. How are we doing so far? Is everybody able to get those? So real quick, let me just show you. So I put in here, I put 3 of them. So this one is the male current overall mean. So if I put them in the list 1, I go to stat, calc, 1 bar stats. It defaults to list 1. So if I just don't tell it anything, it's going to just assume I mean list 1. And then I can pick off my X bar, and I can pick off my S. Is that what you guys got for that 4th box? The male current mean and standard deviation? Does that look familiar? Anybody?
Yeah.
Has anybody done that? No?
Yeah.
So you should get those numbers for...
I think you did it wrong.
Yeah.
It's very possible. I was throwing them in. Let's double check.
0.05.025.
It looks weird. No, they don't look weird.
19.
88, 83, 74, 74. Yeah, they look fine. So, yeah. So for this one, this little collection here, those of you who did that one, did you get X bar equal to 86.6?
2.
86.62, sure.
Yeah.
And S was
9.46.
like that.
What's that for? Oh,
I did it.
okay.
I
Yeah,
just
4th
did
box.
2 decimal places. Can you do 9.46?
Standard deviations always go out. At least we
No, for the mean. For the X bar. Yeah.
Well, crud.
0.025.
What about number 2, the spring 2014 men? Who got this one here?
79.55.
Sorry, do it one more time.
79.55.
And their standard deviation?
10.667.
2. All right. Yeah, that was fun. What about the 3rd box here? The female current? Do it one more time, sorry. 83.65 and a standard deviation of 1, 5. They do 165. 10.148. I love it. You're like, dude, it's the same damn number. What do you want from me? But of course, what's the one thing I'm really picky about? Standard deviation, you go at least 3 places. Yeah.
I don't I've never done
All right. So real quick, obviously in the homework now they can give you a lot more just lists of data. So that's why I wanted to go through this with you guys, so you remember how to do it in your calculator. You're not going to want to do these huge lists of data and get the standard deviation by hand. My God. right? You do not want to do this. So now we can figure out the confidence intervals. Each one has got a different sample size. Every one of them is going to be a 95% confidence interval, but each one is going to have a different t-score, right? So for the first one, degrees of freedom is 18. I mean 95% confident. What t-score did you guys get?
2.101.
Do it again.
2.101.
Yeah, sounds familiar. And then you just got to plug and chug. So for the first set of data, we got 74.63. Give or take 2.101. 10.578. 2.8. Square root of, now what goes in there? 19. Yeah, the biggest mistake I see there, and I'm not picking on anybody. I know one person did this, but I see a lot. You put the 19, not the 18. 18 was just a temporary dude for looking at the chart. 19 is N. So you put 19 where N is. Cool?
Cool.
And then you get,
85.7.
what do you get for your error?
5.1. Are you doing the first one or the second one? The first one.
5.098.
5.18.
1.8.
I just put 5.1.
All right, I'm crowdsourcing this work. So let's see. Oh man, 5 points. Let's see.
Where did the 5.18 come from?
I don't know. Well, now you're speaking up. So I'm asking you guys what you got here. And I got
5.08.
yeah 5.0.
Yeah.
I got 9.9.
I got 0.094.
All right. So we all got like 5.09 something. Roughly. All right. Should be this. And then you just add and subtract it, you get that interval, right? So let me ask you this. Is there anybody who did the interval who actually finished this out?
I did, but I put 0.94.
That's all right. I can live with it.
I put point.
Nito, what'd you get?
I put point.
Jasmine?
For the plus, I got 79.724. And then the minus, I got 69.539.
All right, so that's roughly that interval. What about the second, the males from 2014? You ready to get that confidence interval done? What t-score did you get?
2.080.
2.080.
Yeah.
All right. And then what's your interval? Just skip the work for right now.
74.820
Yeah.
and 84.280.
All right, that's what people got for spring 2014 men.
Wait, I'm confused. Where did you get the 2.08? Oh, sorry.
So let's double check it. Where did I put my T there? So here I got degrees of freedom is 21. You got it? Yeah. All right. I like that. That's the wait and see approach to teaching. How about this third one here? The current females. Marley might not.
Here is 4.75.
Yeah, what t-score did you get? I'm sorry.
I got 2.0.
2.093. Yeah.
2.093.
Yeah.
Yeah.
And then what's the interval?
78.9 to 85.743.
I got a big number.
I got
88.4.
0.399.
All right, let's see.
No, I got 78.9, but for the bigger one, we got 88.3.
What was your mean?
Oh, never mind.
Your mean was
I was wrong.
83.65. All right.
Yeah.
5 down, 5 up. Yeah, it should be 88.
Yeah.
0.399.
All right. Something like that. Okay. That sounds about right. And finally, for the current men, what did you get for your T-score first off?
2.179.
2.179. Does that sound right?
Yeah.
Anybody else who did that one? And what's the interval you got?
92.3.
No, that's the last one.
Whoa.
Sorry, 79.715.
79.72 up to
93.485.
93.49 roughly?
Yeah.
All right, now look at all those intervals. Let's see. So we got, let me collect them here on this other piece of paper so we can look at them. So we got 69.54 to 79.74, 74.82 to 84.28, 78.9 to 88.399, 79.72 to 93.4. Okay. So this kind of goes in order of 1, 2, 3, 4. So this is both from last semester, and then these two are from this semester. See how these two overlap from last semester? So there's a chance that the true mean average of the whole class from last semester would be the same. Is that cool? Because they overlap. This is different from the one I had up on the board earlier where they didn't overlap. So there's a significant difference between the two. Here there isn't because they overlap. And if you look back at the averages themselves, from last semester, it was 74 and almost 80. So just looking at those directly, you're like, well, there's definitely a difference. But remember, these came from samples. So the actual average, who knows where it really was. So there's not enough evidence there. There's not enough evidence there to say that the average between the men and women was different. Because the sample size is relatively small, right? It's not going to be enough evidence. Does that make sense right there, what I just said? Since the confidence intervals overlap, there's not enough evidence that they're actually different, because there's a chance they could be the same. Now this semester, if we look at the two from this semester, they also overlap quite a bit. So if you're a man, you can't necessarily overly celebrate that your average is, the men's average is relatively higher. Because again, this is a sample. I might have just randomly picked some higher scoring men. Plus the men's sample size is pretty small, right? So I can't really say too much about this, but I can say that there's not enough evidence that it looks like they're different. I can't say they're not the same. Does that make sense? Because they overlap. What about the men last semester to the men now? Here's the men last semester. Here's the men now. Do they overlap?
No. Yes.
Yes, they do. Right? So I can't say that there's any difference between the men last semester and this year. Because there's an overlap. And what about the women last semester and the women now?
Yes.
Yes.
They're the ones that almost don't overlap, but they still overlap a little bit. Right? Yes, ma'am.
For the current one, I got a different
Is it really, really different? What'd you get?
80.905 to 92.3. That's what I got.
All right, so a little bit smaller. What'd you get for a T-score?
2.179.
All right. All right, so this are 80 to 92, something roughly? Okay. Now then it might get interesting. Does it? Let's see. Nope, they still would overlap. Okay. All right, cool. So the main thing I want you to get from this is, I definitely, with this handout, I want to make sure everybody remembered how to use your calculator to get the standard deviation of the mean. You're going to see that in the homework. You're going to see that on the next quiz and the next test. We're not done, by the way. I know it sounds like I'm wrapping up. I'm not. I'm just summarizing so far. Right? So guys, an immediate use of this confidence interval is to do what we just did. Do various populations of people and see if they overlap or not. It's a very quick visual of, is there evidence that there seems to be a difference? Now, there is a flaw in using confidence intervals as tests for evidence. And that's the fact that they are built around this number. And of course, this number varies from day to day, person to person, right? If I did it again, went into my spreadsheet and took out another random sampling, the X bar is not going to be the same. The interval is suddenly going to shift around. So this is a quick look to see if it looks like there might be evidence that they're different. And there really isn't any. The closest was that last one, the females. I might come back in with Chapter 8's methods and look at the women more closely with that, because Chapter 8's methods don't have this flaw. So that's a little preview of Chapter 8. Chapter 8 is all about testing claims. I claim that the gas price has gone down. So we go out and take a sample and we test it compared to what it used to be. And see if there's enough evidence. Is it different enough? Right? So that's Chapter 8's inner future. Right now I want to do what I said earlier. I wanted to introduce the T-scores, but now I want to go back and look at the P stuff. Because it sounds like we had some trouble with Section 7.2. So first thing off, let's of course I've now long ago Can I borrow that again? That sheet. Somebody have that sheet from last time? Cool. My fingers. All right, guys. So we talked about this a little bit last time. It's the last thing we did last time. That long week ago. And this little formula for p hat. Well, let me get the lights on. This is kind of using the letters we're used to from NPQ problems. So X from that one was the number of successes. So of course, if I have this, for example, this one says, let's see, take a sample of 652 registered voters, and 459 of them say that they voted in the last election. So you actually don't even need the formula, but just in case you want to put it down, how would I get the percentage of people that say they voted? How would I get that? How would I calculate the percentage of people that said they voted? Yeah, exactly. It's the number of successes, X, 459, divided by N, the total number of people I talked to. So that's why the formula is there, but do you even need the formula? You really shouldn't. You should be able to calculate basic percentages, right? That's all p hat is the percentage you calculate from the, why is it wearing a hat? Sample, right? Population people are way too formal for any like party hat kind of stuff going on. Right? So we got, where'd it go? 459 over 652. And so you're going to love this. Always take your percentages out at least 3 places, just like standard deviations. So try to get 0.7, 0.704. All right. So what's Q hat?
1 minus
Yeah.
0.296.
I love it. Coolness. Cool. And a real quick check. This is the one thing you definitely have to remember from the section with the NAB. One big thing to come out of that was the check for normality. So that's why I don't like that some of my colleagues skip that section, because now you guys kind of understand. I can't use z-scores to deal with percentages unless I know it's normal. And how do you know an NPQ problem is normal enough? You check. What do you check? Yeah, what's greater than 5? NP and Q. Right? That's what you check. So in this case, I don't have P. I got P hat. So that's the best I got. So I've got to use it. So what's N? Now here's the funny thing. Somebody see what's kind of easy about what N times P hat is. N times P hat should be X. There's no work to do that. Right? So as long as the number of people who said yes and the number of people who said no, or whatever the situation is, if they're both bigger than 5, you're fine. Because what's NQ hat going to be? The rest of the people, right? And how many are the rest of the people? Yeah, 193. Good. Or you can check it. You can do 0.296 times 652 and see that you get roughly this. You guys with me? Let that be easy. You got to love that. What's NP hat? It's freaking X. Of course it is. Right? It just is. Or do the work. Who cares? You'll come up to the right answer anyway. So both of these are... Can't remember this book if it says at least or greater. I can't remember. Depends on which book you're using. They say different things. And so together that means that this is normal enough. So then I'm allowed to take that 99% and translate it into a z-score. I could not do that if it wasn't normal enough. And what do I have now that'll help this make this easier? T-score chart, confidence interval, two-tail. 99% confidence will have how much? 1%, right? So if I look at the T-chart, 1% and two-tail, so the first column. What's my degrees of freedom? Not degrees of freedom. I want a z-score, right? Mm-hmm. So I go all the way down. And what do you get? 2.576. I love it.
Wait, what?
Let me do it again.
How do you look that up?
I don't know. Hold on. I got to remind myself. So, of course, I just turned it around, but no. Oh, I don't want to get rid of that.
So
All right.
0.01.
Yeah, so again, you want 99%, so there's 1% in two tails, right? Or 0.5% in one tail. Either way you look at it, you're in the first column. You want a z-score, so you're going to stop anywhere? If you stop, you're going to get a, I don't want that. I want a z-score. They'll go all the way down.
Oh,
And what do you get? 2.576. I like it.
2.57.
Yeah, so I know z is 2.576.
I just.
Right? 2.576.
So why don't you stop?
What do you mean? Oh, because I don't want a t-score. I don't want a t-score. If I stop somewhere, I'm going to get a t-score for that degree of freedom. I want z-scores. And here's the thing. You ready for this? This is beautiful. NPQ problems. Either they are normal enough and you use z-scores, or they're not normal enough and you don't do anything. T-scores don't have a damn thing to do with these. Let me see why. This is one reason. This is the thing that was confusing a lot of you guys. Do I do anything about standard deviation here? And what's the whole thing about t-scores? I have to not know this, but in this case, I kind of assume I do. I'm making it myself. P hat, Q hat, divided by n square root. That's going to be my standard. I know it. So I don't need t-scores ever. So an NPQ problem is z or nothing. Sounds like a note. Right? T-scores only come into play with means. I'm going to try to find a confidence interval for a mean. Okay, maybe. So I got my P hat, I got my Q hat, I got N, I got Z, that's all I need. So now I got my formula, P hat, give or take, Z, square root, hat people in there, and N's. Okay. So I just plug and chug. P hat is 0.704, give or take, 2.576 times this. And this is where you got to be careful about plugging this in the calculator. Where did, oh yeah, 652. Let's see. Yeah, I can do it.
N is 459, right? Yeah.
Say again, sir.
Oh no. N
Careful
is
now. Yeah,
652.
that's another. That's the biggest mistake is. Well, actually, for this problem, is using x instead of n. So it's always something to do with that n dude. So here definitely needs the full n, not just the number of people who said yes or no, but everybody you talk to.
So X is success.
X is success, and again, success doesn't have to be a happy thing.
Yeah.
Percent of people that died, right? That's not happy. So, but it's just the percent of people that, the number of people that match what you're looking for, and it's going to be all the people or things that you looked at or talked to in this case. So let's see. We got. What do you calculate first? Crazy. 2.576. So if you got one of the old calculators that don't grow the square root symbol over, do not close your parentheses until you're done with everything that's supposed to be in it. So it would be 0.704 times 0.296 divided by 652. Then you close it. If you close it too early, everything else that comes after is outside of the square root. That sucks for you. Right? Garbage in, garbage out. If you have one of the new ones where the square root symbol grows, well, good for you. It'll be easier. Sorry, I'm jealous. I don't have it. So enter. So we almost always get somewhere between 3 and 5%. So in Gallup, I showed you Gallup, and Gallup had like 4% down there. So we just got 4.6%. Right? 0.704, give or take, 0.046. So 4.6%. So now you finally understand, especially now we're getting really close. Obviously, tomorrow is election day, by the way, right? Find a way to go vote. If you ever see people talking about the polls and they say it's this, and at the bottom you see plus or minus 4, you know exactly where the hell I came from. If I wanted to make this number smaller, what's one immediate way I could do that?
Sample more people.
Yeah, sample more people. That's the more direct, honest way. Or I could just make my confidence level smaller. Right? I can make it. I could just be at 90% confident. Won't that make that smaller? You're going not out as far because you don't have to catch as many people to be 90% confident. Maybe. So what do you get here? If you subtract it, 658. 75, yeah, good. So we are 99% confident that the true percentage of people that voted is roughly 66 to 75%. So if we look at the records and we see that 52% of the people voted, in reality, what does that mean about the people we talked to? Some of them must have lied, right? There's a very small chance that my confidence interval is that wrong. It's really strong evidence that somebody was lying to me. Right? We don't like that. Let's see. All right. So that's section 7.2. Does that help you guys out with some of your troubles?
Yeah.
I mean, you really don't have to be told a lot. It might feel like sometimes they're not telling me enough, but you don't have to be told much at all. One other quick little thing that's in 7.2. And just to kind of accumulate everything we've learned so far in chapter 7. We got this guy. We got this guy. We got this guy.
Can we put that on our formula sheet?
Oh, hell yeah.
Oh, hell yeah.
All right, you got those three main dudes. Then you got like two offshoots, one of which we talked about already. Remember this little dude, N? What? This is what they ask you. How many people or how much would you have to collect? How big would your sample have to be within this much? So they tell you what the error is, and you got to figure out what the sample size would be. It's what I call the feasibility study. Johnson, we got to be within 1%. Well, we need to talk to 18 million people. Well, okay, shit. I can live with 2. Right? I mean, is it feasible for us to talk or look at that many things? So there's one more, of course. This one, and to tell you honestly, there's a corollary to this that's this here. I mean, there's just so many analogous things in statistics. If there's a Z, it could be a T. If there's a sigma, it could be an S. Right? So if I know the population area, I use this. If I don't, I use that. Okay, cool. But there's one more main one, and that's dealing with percentages. You good? Okay. And so let's derive that really quickly. That's one of your favorite words, derive. So I do it the same way I did before. Which part of this is the error?
Z.
Yeah, this part here. So I say the error is this. Right? And I solve for n. So what's the good first step?
Get the Z. Or no. Calculate P and Q.
No, I don't have anything to calculate. It's just purely variables now. Right?
Square.
Yeah, squaring is not a bad idea. Get that square root out of the way. So if I square both sides, I'll do this side. Okay. What do you get on that side? Yeah, Z squared.
Times P.
Yeah, so that frees, that's Z squared, and then this cancels, right? Square and the square root cancel. And then, of course, I can just do... Remember that? Divide that down, multiply that up? Okay.
Multiply by n, divide by...
Let me ask you, if you did not know what P hat and Q hat were, what would you use? If you don't know the percentage of people next door that are men, what would you use?
0.5.
Yeah, beautiful. I love it. You'd use 50-50. And to be honest, that if you don't know what P hat and Q hat are, mathematically, using 50% and 50% will make n the biggest it could possibly be. So it's a way of covering your ass for not knowing something. So if you don't know what P hat and Q hat are, and in the book they have this. In the book they make it look like it's a whole different formula.
Oh, I hate that.
Where the hell did they come up with 0.25? 0.5 times 0.5. Right? So it's not a new freaking formula. It's just 50-50 if you don't know, right?
Yeah.
That's your best guess. So this one, again, you use this if they say, how big of a sample do you have to take to be within 3 percentage points of the true percentage of whatever. You use this formula here. All right, so let me point one thing out. And then pretty much have to let you go this time. on the back. You can read as much as little of this as you want. This is getting into chapter 8. This is the entire process all laid out. So some of it will sound very familiar. Some of it will sound like nothing you've ever heard of before. So we will get into that next time.
Fun.
Yes, fun.